This video is part C of the MiPACE training series. In this section, we focus on how to read the results produced after the inputs are completed and the model is executed. We'll begin with the output for freeway and multi-lane facilities. The output summary brings the main project information, analysis setup, and performance measures into one report page. At the top, the geometric layout provides a quick visual check that the lane closure, segment sequence, and the work zone configuration were represented correctly. The Q section identifies the maximum upstream extent of congestion and the time when that maximum occurs. The delay section reports the total vehicle miles traveled, vehicle hours traveled, total vehicle hours of delay, speed delay, and backup delay. Speed delay reflects vehicles moving below the reference operating speed, while backup delay reflects the additional delay caused by queuing. Finally, the cost section converts the delay impact into passenger car and truck part road user costs. Costs are separated into direct demand costs, reduced demand cost, and the total demand cost so that the effects of demand reduction can be reviewed separately. The queue and delay charts show how congestion changes during the day rather than only reporting one maximum value. The queue chart shows the length of the queue at 15 minutes interval. This helps identify when congestion begins, when it reaches its maximum, and when it clears. The peak in this chart should correspond to the maximum queue length and time of maximum queue reported on the summary page. The delay chart separates the traffic impact into speed delay, backup delay, and total delay. Speed delay occurs when traffic is moving, but at speed below the reference condition. Backup delay becomes important when queues form and vehicles experience additional waiting due to congestion. When reviewing the results, use the two charts together. The queue chart shows the extent of the congestion, while the delay chart shows the severity of the operational impact over time. The speed heat map provides a times and space view of the simulated traffic conditions. Time is shown across the vertical direction, while roadway is represented by the CTM cells created from the geometric segment layer. Each colored cell represents the simulated speed for a specific location and time interval. Higher speed areas indicate uncongested or less restricted conditions, while the lower speed areas indicate the congestions or queue formation. The heat map is useful because it shows where congestion starts, how it propagates upstream from the work zone bottleneck, how long it remains on the corridor, and when it begins to recover. This view should be interpreted together with the queue and the delay chart. The chart summarizes the magnitude of the impact over time, while the heat map shows where that impact occurs along the facility. Next, we'll review the output for one-lane, two-way flagging operations. The one-lane, two-way output summary reports the results separately for the closed and open directions, because each direction forms its own queue and receives service at different points in the flagging cycle. The analysis information confirms the selected facility type, facility name, work zone length, and active flagging period. Capacity section reports the saturation flow for each direction. This represents the directional discharge rate used when traffic is released through the one-lane section. The speed section reports the adjusted operating speed for the closed and open direction. The queue section reports the maximum queue length and the time of maximum queue separated by the direction. The delay section separates vehicle hours of delay by direction and also reports the total vehicle hours of delay across the whole operation. The cost section then converts those directional impacts into road user cost and reports the total cost for the flagging scenario. Plots show the cycle-by-cycle queue in vehicles for the closed and open direction. The repeating sawtooth pattern reflects the flagging operation. A queue builds while the direction has been held, then decreases when that direction receives service. If the queue does not fully clear during a service period, the remaining vehicles become a residual queue and are carried into the next cycle. This is important because unresolved queues can accumulate over time and create much larger impacts later in the day. In this example, both directions show substantial afternoon growth. The close direction develops larger Q, which is consistent with the maximum Q values reported in the summary page. When interpreting this slide, remember that the Q profile is reported in vehicles, while the summary page reports the maximum Q length in miles. The model performance table shows how delay and cost vary by hour for each direction. Results are separated into the close direction and the open direction so that the user can identify which approach is more effective. Only the active flagging hours contain results. Average delay measured in minutes per vehicle represents the average additional time experienced by each vehicle during that hour. Total delay measured in vehicle hours represents the cumulative delay for all vehicles in that direction during that hour. User cost converts the hourly delay impact into monetary terms. So use this table to identify hours that contribute mostly strongly to the overall delay and costs. Those hours are the most important periods to review when considering changes in the closure stages, work zone length, and flagging operation. This completes Part C of the training covering the output of the tool. Part D will focus on the case example described in the user guide of the tool. Thank you.